So yesterday we were discussing loops and also we discussed, yeah. Okay. Okay. Yeah. So yesterday we were discussing loops and also we discussed how to print some patterns, right? Like we discussed how to print a row of stars and like a rectangle and a triangle, right? So we discussed this example, like in the first row there is 1 star, second row 2 stars, third row 3 stars, and so on. Fifth row 5 stars. So simple thing is, whenever this is a 2D pattern, this is not a 1D pattern. If it is just a 1D pattern, which means in a single line you have some n number of stars, you have only one loop. But if you have a 2D pattern, which means there are some rows and there are some columns, then you need two loops, that is nested loops. Okay, one loop inside another loop. So what did we say? We said, let's assume I iterates over the number of rows and j iterates over the number of columns. Okay, and I goes from 1 to 5. In this case we have only 5 rows, and j goes from 1 to I. Because, so how to know what is the relation between number of stars and the row number? You start with a simple take any example and count the number of stars in each row and try to find the pattern. Like in the first row there is 1 star, second row there are 2 stars, third row there are 3 stars, fourth row there are 4 stars, and so on. So in ith row how many stars will be there? I stars. That's all. So j goes from 1 to I. So that is the relation between number of stars in a particular row and the row number. Okay, so we saw that code also yesterday. So this is triangle with 50 rows. I goes from 1 to 50, j goes from 1 to I. So if you print this, you get this triangle, right? Okay. Now let us try to invert this triangle. So suppose I want to print a triangle like this. First row 1 star, next row 2 stars but to the left, next row 3 stars, and then 4 stars, and then 5 stars. Now how to print this? Yeah, you should print spaces. So now in the previous case we just had to print stars, we didn't have to print the spaces after the stars. But in this case we necessarily have to print the spaces. So in each row we should print both the spaces and the number of stars. Okay, so in the first row you should count how many spaces you have and how many stars you have. So here you have 4 spaces and 1 star, and in the second row you have how many spaces? 3 spaces, 2 stars. Third row 2 spaces, 3 stars. Fourth row 1 space, 4 stars. Ith row, that is fifth row, 0 space, 5 stars. But ith row, 5 minus I and I stars. Okay, so because we have 5 rows here, you have 5 minus I. If we have n rows, it will be n minus I. Okay, so here the relation or the number of spaces and the number of stars is not just a function of I, but it is also a function of n. In the previous case, number of stars is just a function of I, not the function of n. N is the total number of rows. In this case, number of stars and number of spaces is a function of n as well as I. Okay, so we need to print n minus I spaces and I stars. Okay, so let's quickly do that. So let's assume, okay, 50 rows. Now total how many loops we will have? 3 loops. So how are they arranged? So are they nested inside each other, or how are they arranged? These 3 loops are nested inside each other, or what? Yeah, exactly. 2 loops are inside 1 loop. These 2 are not nested with respect to each other. They are one after another. Okay. So the outer loop is for the number of rows, and then there are 2 inner loops. The first loop is for spaces. Second loop is for stars. That's it. Both are independent loops. Okay. So I goes from 1 to 50. J goes from, so let's say not 50, let's say n. And let's scan this n, n from the user. So I goes from 1 to, yeah, we can say 1 to n, yeah. And j goes from 1 to, I mean not stars, spaces. How many spaces? N minus I spaces. So j goes from 1 to n minus I. So I print spaces, and then how many stars I should print? I stars. So j goes from 1 to I. It will be star. And then you print a new line. After this sequence of spaces and stars are done, print a new line. Okay. Yeah, I should give n. Let's say 10. Got this. Let's say 50. Got this. Okay. That's it. So here, so basically what you should try to do is, whenever such a pattern is given, try to find the relation between the number of characters in a particular row and the row number, or if necessary, the entire number of rows. The function, it should be a function, it should be sort of translated into a function of I or n, or both n and I. That's all. Okay. Now, suppose I want to print not a right angle triangle, but an equilateral triangle like this. Okay. Then what to do? There are 2 ways. One is, given the way characters are printed, you have to put, you cannot put just 2 stars and expect them to come one before the above star and one after the above star. It will not happen. You have to put a space in between. So that is one way. So all we need to do is just add a space. Copy this. Instead of star, make it star followed by a space. Okay. You see, got an equilateral triangle because you're spacing them. All right. But suppose I don't want spaces between the stars. I want only stars. Then what to do? There is only one way. Instead of star space, you should sort of give sorry. How does it matter? Both are same. I said I don't want space between stars. You are giving space before instead of after. You will still get spaces between stars, right? Okay, space, stars, space. So how many stars should I give? Yeah, so simple way is, each row will have only odd number of stars. You need to sort of skip even number of stars rows. You will have 1 star, then 3 stars, 5, 7, and so on. Okay. So that's a slightly different pattern. So how does that look? So 1 star, 3 stars, 5 stars, and 7 stars, and so on. Okay, so now we need to find the pattern. So let's assume there are 4 rows. N is 4. So in the first row, how many spaces we have? 3 spaces. Or let's start from the third row. Third row has 1 space and 5 stars. And this space you need not print, but say sometimes in the lab problem or in the exam, if you are asked to print the trailing spaces also, you should print that as well. Okay, so let's work out the example where we will print the trailing spaces also. Okay, so sometimes trailing spaces may be different from the preceding spaces. In this case, they are same, but in some other cases, they are like in the previous examples, they are different. Like in this triangle, if you are asked to print trailing spaces, then you need to print that as well. Okay. Anyway, so here, 1 space, 5 stars, and 1 space. This is third row. And in second row, 2 spaces, 3 stars, 2 spaces, 2 spaces, 3 stars, 2 spaces. This is the second row. And in the first row, 3 spaces, 1 star, 3 spaces. This is the first row. In the last row, fourth row, 0 spaces, 7 stars, 0 spaces. This is the fourth row. So now try to find the relation between the number of spaces, number of stars, and I, or n and I. Sorry, spaces are n minus 1 to 0 means, okay, here, okay, 3, 2, 1, and so on. So in the ith row, how many spaces you will have? Yeah, n minus I. Actually, what you can do, you can write the row number also here. Okay, so now find the relation. In first row, you have 4 minus 1. In second row, you have 4 minus 2. In third row, you have 4 minus 3 spaces. In fourth row, you have 4 minus 4 spaces. So n minus I spaces. And how many stars? In ith row? Yeah, 2i minus 1. 2 into 3 minus 1. 2 into 2 minus 1. 2 into 1 minus 1. 2 into 4 minus 1 space stars. 2i minus 1 stars. And again, n minus I spaces. So now you will have one outer for loop for the rows and how many inner for loops? Only 2. 3, right? You need one for preceding spaces, you need one for stars, and you need one for the trailing spaces. So you need 3 loops inside, right? This was this. So this is number of rows, fine. And then how many spaces, preceding spaces? N minus I spaces. So this will remain the same. All right. This same thing I will copy. Same number of spaces are printed. Only here, number of stars will be 2i minus 1. No space between stars. That's it. Fine. So now there are no spaces between stars. Okay. The simple thing is each row has odd number of stars. In the previous case, you have all stars, 1 star, 2 star, 3 stars, but there are spaces between stars. Then you won't get this kind of triangle. Not this one. Where is that? Oh, it's gone. No, that's gone. That's gone. So let me just compile. You see this one. So here there is a space between here 1 star, 2 stars, 3 stars, and so on. But if you compile the 11th one, no spaces between stars, 1 star, 3 stars, 5 stars, 7 stars, and so on. Okay. So that's all. So any pattern given, you try to find the relation between number of characters in a particular row and the row number, and if necessary, the total number of rows, n and I. That's all. Okay. Fine. Now let's move on to the next topic. That is arrays. So arrays are derived data types. So what are derived data types? So far, what we have seen are primitive data types. You all know int, char, float, double. These are primitive data types because they cannot be broken down further. They are not built out of some other data types. They are basic. They are like atomic data types. But using these, we can build more complex data types. One example is arrays. Another example, does anyone know? Sorry? String is a kind of array. Any other kind of data type? Derived data type, you know? Linked list, yes. That's not a derived data type. That's an abstract data type, yes. But even before that, linked list is made up of what? Nodes. And node is made up of? Node is not just one data type, right? Node is a structure. It's a struct. So another data type is struct. Array is a homogeneous data type. That is, you can have an array of integers, or you can have an array of characters, or you can have an array of floats. You can have an array of doubles. But you can't have an array of one float, two integers, three characters, something like that. No, you can't have a mix of data types. So array is a homogeneous data type. Okay, if you want a heterogeneous data type where you want two integers, some floats, some character, you know, a mix of these things, then that will be a heterogeneous data type, that is struct. We will see structs later. Today we are looking at arrays. Okay, this is clear. And why do we need derived data types? Can't we do with primitive data types whatever we are doing? Why do we need an array data type? But why do I need to store? Whatever I want to do with strings, I can do with variables also. I mean, I can do with characters, character data type also. Suppose I want to read a file. I'll just say char ch, read one character after another, print that character. Yeah? Understandable to the user. User doesn't even know what code is there. Yeah.
Suppose we have I, we want to change the value of I, the before value will be arrays. But in the case of arrays, we can store multiple values in the same.
Yeah, but why should I store multiple values? I can use multiple variables.
In a for loop, want to store all the.
We
can give the index using the I, so A of I, and we can store multiple things.
You're telling me what we can do with arrays. I'm asking you, why do we need arrays in the first place? Whatever we can do with arrays, can't we do it with variables, primitive data types?
To reduce lines of code.
To reduce.
When we can manipulate all the values.
Yeah, why did you come even now? You could as well not come. Why did you come now? After half an hour? Just leave. Leave. No, that's what I meant. You don't understand the meaning of the word leave. Yeah. Yeah, see, it's simple. It is not like we can't do whatever we can do with arrays, we can't do that with primitive data types. That's not the case. It is just that our life becomes much more simpler with arrays. So it's a degree of convenience and not a degree of quality. It's a quantitative difference, not a qualitative difference per se. In the sense, say, suppose I have now, there are so many students in the course. I want to list all the students, say I want to sort their marks, or I want to store your data. One way of storing with whatever knowledge we got so far is I have to sort of create a different variable for each student. It can be student name or student roll number. So suppose I have 100 students, then I need to create 100 variables, student 1, student 2, student 3, and so on. So I have to store 100 different students. Now suppose if I want to iterate through them, okay, print me the values of these 100 students. What do? I have to write 100 print statements. Print the marks of student 1, student 2, student 3, and so on. I can't loop, I can't iterate over them, right? Instead of student 1, I can give your name itself. Okay, some student X marks are these, some student Y marks are these, student A, student B. So I have 100 different variables. They are completely 100 different things. There is no commonality between them. So I can't access. Now just imagine if I have 1 million. I need to create 1 million variables. I need to store 1 million variables. I can't loop through them. I need to write 1 million print statements or 1 million scan statements. All these things I need to write. And if I mistake one variable to another, entire thing gets disturbed, right? So when you have homogeneous data and all it needs is to just list them one after another, okay? And the name does not matter. This entire thing can be given a name. Each individual cell, each individual element in the list need not be given a separate name, because there the name does not really matter. It's just an element in the list, okay? And I want to deal with this list as a whole. Like I want to print this entire list, or I want to scan this entire list, or I want to sort this entire list. For all these things, it is easy if we have arrays. It will be difficult if we use different variable name for each element. That's all. It is not like you cannot do it with individual variables, but it will be very laborious and it will be extremely like excruciating task. Okay, so that's the simple thing. So arrays make your life much simpler. Another thing, like if you want to loop, I can't loop through 100 different variables. So I have to separately write a print or any statement. Anything I want to do with them, I have to write a separate statement for each variable. But if I have an array, all I need to do is, okay, print the first element, second element, third element, and so on. Loop from 1 to 100, print all the elements of this array. That's it. One loop will do the job. So arrays and loops go hand in hand. So arrays are a very good application of loops, and loops are very important for arrays. Okay, so I hope now you understood why we need arrays. All right. And also semantically, meaning wise, array as a unit is easier for us to grasp and code when you're dealing with that kind of data. You see, later when you deal with data structures, we you will look at different kinds of data structures like a queue or stack or a tree or a graph. So all of them can be again broken down into individual variables, but having these data types will help you, will make your life easier to do some tasks. Suppose if I want to find the shortest path from one point to another point, it is easier if I represent it as a graph. So graph data structure is useful for some purposes. And suppose if I want to store all the data related to a student, it is easier if I store that entire student as a struct, student's name, student's age, student's address, student's marks. All these things will be like one unit. Okay, now get me all the students' details, or get me these 5 students' details. So rather than storing, suppose each student has 5 parameters or 5 attributes: name, age, roll number, marks, etc. Now, if I want 5 students' details, if I use only individual variables, then I need 25 different variables. Okay, student 1 marks, student 2 marks, student 3 marks, student, similarly student 1 address, student 2 address, student 3 address. All these things, that is too much of a headache. But having a separate structure or struct for one student will make it easy for me to both code as well as grasp the data. Okay, so data structures, you will understand these things better. You will do many more examples later. But these are all sort of building blocks towards that. What you are learning in this course are building blocks for that. Okay. All right. So arrays are derived data types which can hold more than one value at a given time. Although they can hold more than one value, all the values should be of the same data type, like int, char, etc. Hence, arrays are also homogeneous data types, unlike structs, which we'll see later. Okay. So arrays are stored in the RAM like this. So we all know RAM. Like when you buy a computer, you see how much RAM it has, right? 8 GB, 16 GB, whatever. So what do we mean by that? 8 GB means 8 gigabytes, or 16 GB means 16 gigabytes. But what are gigabytes? Each gigabyte is how many MB? 1000 MB. Each MB is how many KB? 1000 KB. Each KB is 1000 bytes, right? So a RAM is nothing but a sequence of bytes. Okay, suppose let's take a smaller example. So suppose my RAM size is 100 bytes or 1 kilobyte, which means 1000 bytes. Okay, so the RAM will look somewhat like this. So I have different cells. So each cell width is 1 byte. Okay, so you can give them an address. So this is the first byte, second byte, third byte, fourth byte, and so on. This is 999th byte and 1000th byte. Okay, so each byte is called a word, the width of RAM. Now, say when I want to store an array in the RAM, the array needs to be stored contiguously, which means you can't, suppose if I have an array of size 100, I can't store 10 elements here, 20 elements there, 5 elements here, 4 elements somewhere else. I can't break it up and store at different locations in the RAM. The RAM should have 100 contiguous memory locations free for this array to commence it. If those 100 memory locations are not free contiguously, then array cannot be placed there. Then we say the RAM is sort of full, or you need to readjust some other locations in the RAM, move them around, make space, 100 contiguous location space, and then fit the array there. Okay, so an array is a contiguous memory location sequence. All right, so array can be created anywhere. Suppose if my array is of characters. Okay, suppose my array has 3 characters. Then I can say place my array here. Suppose this first byte is filled. I can use the remaining 3 bytes. Okay, this is an array of 3 characters. So, but suppose if my array has 3 integers, then how many bytes I need? Huh? If my array has 3 characters, how many bytes I need? What is the size of char in terms of bytes? Each character takes how many bytes? 1 byte. So 3 characters will take how many bytes? Then why are you saying 4, 24, all these things? Huh? 3 characters will require 3 bytes. So array will need only 3 bytes in the RAM. That's it. Now suppose if I want to store 3 integers, how many bytes I need? 12 bytes. So somewhere I need to have 12 bytes of free space in the RAM. Okay. So in that case, suppose it starts from 2. So let me write this 5, 6, 7, 8. So, okay, let me use this one also. So first integer will take up 4 bytes. Next integer will take up 4 bytes. Suppose my array has only 2 integers. Then my array takes up all these 8 bytes to store 2 integers. But in the previous case, it had to store only 3 characters. So it took only 3 bytes. Okay. So it depends on what elements you want to store, how much space each element takes. Just multiple of those many elements with their size will give you the size of the array. That much space should be there in the RAM. Okay. So that's it. Now, so if you look here, so there are 3 series of numbers. It's quite simple. These are the elements in the array or elements of the array. These 11, 9, 17. Suppose these are the marks of the students. I want to store them. First student has 11 marks, then next student 9 marks, 17 marks, and so on. These are the elements in the array. And these are the relative positions of the elements in the array. That is first student, second student, and so on. Now, if you notice, the first position is starting at 0, not 1. You will see the reason later when we get into pointers, but this is a very important point. any array index starts from 0, not 1. So if an array has n elements, the index goes from 0 to n minus 1. If an array has 10 elements, index goes from 0 to 9. In this case, how many elements the array has? 12 elements. So the index goes from 0 to 11. Okay. So if I want to access the first student's marks, I have to go to index 0. If I want to access the fifth student's marks, I have to go to index 4. Okay. And what are these? Yeah, memory locations or address, absolute address. Absolute address of each element in the RAM. Right? So like if you see here, in this case it starts at 1, but suppose RAM is suppose the integer, first integer you are not storing here. Okay, so you have much larger RAM. Next integer you are storing here. Okay, so suppose my array is only this. So this will be my first integer. So this is at index 0. This will be my second integer. This will be at index 1. Okay, but what is the absolute address of this integer? Number 9 in the RAM. Absolute address of this integer is number 5 in the RAM. Okay, so array can comment it anywhere in the RAM, right? You have million cells, million bytes. In 1 MB you have million bytes, which means you have million such cells. So array can comment it maybe at 1000 cells or 1 lakh number cell or any cell. With respect to that array, that will be the first index, but the absolute address will be 1 lakh or 9 lakhs or whatever it is. So that is the absolute address. Okay. So this is absolute address in the RAM. So if you see these are the integers, right? Since each integer takes 4 bytes, here the addresses are separated by 4 bytes. First integer is stored at location 200. Next integer is stored at 204, next 208, next 212, and so on. But if they were characters, then the addresses will be 200, 201, 202, and so on. Okay. So first integer is taking 4 bytes. It is taking all the 4 bytes, 200, 201, 202, 203. All these 4 bytes are taken by the first integer. Then 204 to 207 are taken by the second integer. 208 to 211 are taken by the third integer. Okay. But if they were characters, only 1 byte is taken by a character. Okay, so this is something which you need to keep in mind, but mostly we don't deal with these absolute addresses. Mostly, even when we deal with pointers, we don't need to know the exact number. We just need to know where it is. We will use pointer variables, so we don't need to know the exact number. Okay, so these numbers, actually these are given only for sample. The actual numbers are not so small, 200, 204. Actual numbers are much bigger. So when you print them, you will get a large hexadecimal number. Okay, so this is only for understanding. Usually we don't deal with this. We deal mostly with the indices. Okay, indices and the values. That's all. Absolute address we don't deal much. All right. So okay, so before we come here, normally when you declare or define a variable, what all you need? What all do you specify? No, not array. Normal primitive data type. Suppose you declare an integer or any variable. What do you specify? Data type and name of the variable, right? Same thing here, but you have one additional thing. What is that? Size of the array. So you need to specify the data type of the array, what kind of data types elements it is holding. Second, name of the array, and third, size of the array. Okay. So these are different methods in which you can declare an array. So this is the first method. So here you see, you specified the data type, what kind of array it is. You're coming now. what kind of array it is, what is the array name, what is the array name, and what is the size of the array. Okay, so this is saying that this is an array of integers and the array name is A and it stores 4 integers. Okay, you need to specify the size also beforehand so that that much size is allocated for that array in the RAM. If you don't specify the size, we don't know how much space to allocate in the RAM. All right, so it looks okay. Suppose if you're saying 1 million elements, I need to see whether my RAM has so much space or not. If I don't have that much space, then I can't allow you to declare that array, right? So you need to tell me the size beforehand so that I reserve some space in the RAM at some particular location. Okay, all right, so this is declaration, fine, and this is initialization. You see, for any variable, any data type, primitive data type or derived data type, whatever it is, there are 2 things: declaration and initialization. So in terms of primitive data types, what is declaration? Suppose I say int x, this is declaration. What is initialization? X equal to some value. Suppose I say x equal to 5. Okay, so these are 2 steps. It is up to us. We can separate these 2 steps or we can combine these 2 steps. Usually, if we know the value beforehand, we combine them. So we can combine declaration and initialization in the same step if I know the value. If I don't know the value, I give only declaration now and I initialize it later, or I get the value from the user, whatever it is. Okay, similarly in an array, you can separate both or you can combine both. Okay, this is an example where you combine both. In this case, I know exactly what all elements go into the array. I know all the 4 elements that go into the array, that is 2, 5, -3 and 1. Okay, so since I know the elements, I can combine declaration and initialization. I am declaring the size of the array, name of the array, data type of the array, and I'm also telling what are the values of each element. Okay, so this is combining both declaration and initialization. This is one way of declaring and initializing the array. Another way is, suppose I don't know the values of the elements beforehand. I only know the size of the array. Okay, suppose like an exam is conducted. I know there are 600 students in the course. I declare an array A of 600. I don't know the marks beforehand, right? So I just declare the array and key. As and when the exam is over, as and when I get the marks, I fill the marks in each cell. Okay, first student so many marks, second student so many marks, and so on. So I necessarily have to separate the array declaration and array initialization in this case, because I don't know the marks beforehand. I only know the number of students. But suppose if I know the marks along with the number of students, then I can use this method. If I don't know, then I have to separate declaration and initialization. All right. And in this case, when you are initializing in the declaration step itself, so this is the format. You need to give the values in curly braces, and the order is important. It is not a set. Just because you are using curly braces, it's not a set. This is different from mathematical notation. This is a array. This is an array. The order is important. So first element goes into the first cell, second element goes into the second cell, and so on. Okay, that is one thing. Another way is, suppose I am giving the values during declaration itself. Okay, then this size is optional, because the number of elements in the list is telling me 2 things. One is how many elements are there, and second, what are the exact elements. Okay, so since I not only know what are the exact elements, I also know how many elements are there. I can get the number of elements from this. So this can be filled by the compiler itself. But suppose I don't know the number of elements. I neither know their values nor I know the number of elements. Then you cannot declare like this. This is wrong. In this case, you can leave it empty because you can get the value from here. But in this case, you can't leave it empty because you don't know how many elements are there. And if you don't know how many elements are there, the RAM will not know how much space to allocate. Okay, so directly or indirectly, you should know the size of the array. Either you specify it directly or you get it indirectly from the elements which you are storing in the array. If none of this information is there with you, then you cannot declare the array. You have to give some number. It is better to give a higher number than a lower number. Suppose I know max this room has 300 students. Now it's not necessary that all 300 students will fill this room, but max 300 students can come in this room. So I will declare an array of 300. But at any point of time, I may have only 250 or 270 students. That is okay. But if I declare an array of only size 100 or 200, then I can't store all the values. Okay, so that is the idea. And you can also declare an array like this is the example which I'm saying. Suppose I know max 4 students will be there. Right now there are only 2 students. Suppose these are their seat numbers, whatever it is. 2 students may come later, but I am keeping space for them. Okay, so when you declare an array like this, some information you know, some information you don't know. The remaining information will be filled with zeros. Okay, so 2, 5 will go to the first 2 cells. The remaining 2 cells will be initialized to zeros. Okay, so let's quickly look at some codes. Suppose I declare an array of size say 4, and suppose I take these values from the user. Okay, now one way of taking these values from the user is I take each number from the user. First element is 0 index, second element is index 1, 2, 3 and so on. Okay, so take the first element from the user, second element from the user, third element from the user. And now I also want to print their values. Okay, so this is one way of doing it, right? So you see one thing, when we use A of 4, it is declaring the size of the array. It is not telling me the index number. But later, whenever you use A of some I, there I is not the size of the array. I is the ith element. I is the index. Okay, so this is the only line where you will see the size of the array in brackets. In no other scenario, you will see the size of the array in brackets. In brackets, you will always see a number which is less than the size of the array. If the array size is n, you will see A of n only in the declaration statement. You will never see A of n in any of these statements. It will always be 0 to n minus 1. Because the index goes from 0 to n minus 1. You are trying to access an element in the array in all of the scenarios. Okay, so let's try to run this. So it's waiting for my input. I'll give something 4. Now I can give any number of spaces and new lines in between. It will ignore all of them because it's waiting for an integer. Okay, 4, 9, -1, 3, or yeah. Okay, I should give sort of space or new line. Let me give space. And then finally I'll print a new line. Okay, 4, 2, 9, -3. It stored all the 4 elements and it printed them. Okay, now this is a cumbersome thing. Just because there are 4 elements, I gave separate elements, scanf statement for each element and printf statement for each element. But if there are 100 or 1000 elements, it will be too cumbersome. So what to do? Use loops. So all we need to do is for int I equal to 0. You see, earlier when we were using loops, I went from, say, if we had to print 50 rows, I went from 1 to 50. It doesn't matter whether you go from 1 to 50 or 0 to 49 or 2 to 52. It doesn't 2 to 51. It doesn't matter because you're not dealing with arrays. But when you're dealing with arrays, it is better you start I with 0. Okay, don't write 1 to 4. I goes from 1 to 4. Then the array goes from A of 1 to A of 4. That is wrong. Array should definitely go from A of 0 to A of 3. Okay, so I equal to 0, I less than 4, or you can write I less than or equal to 3. But usually I less than n is easier to remember. You scan here. What should I write? I. Okay. Same thing. So let me copy this. Okay, let me use space and let me print a new line. Yes, we can. We can. You can scan and print in the same loop also. But suppose if I want to print them in reverse, then I need to go. The next for loop will start from n-1 to 0. Okay. So first let's do this. Okay. Now let me print them in reverse. So I will go from 3 to. So what should I write here? Greater than or equal to 0. What should I write here? I minus minus. That's it. Okay. Missed brackets. Eight 9 0 12 12 0 9 8. Okay. Fine. Now, suppose if I know the values beforehand, then I need not even scan them from the user, right? So I need not scan them from the user. I can give them here directly, whatever, 2, 3, 0, minus 5, 2, 0, 2, 3. Now I'll print them in normal order. Yeah, so I gave the elements already. I just printed those elements. Fine. Now, suppose I there are too many elements. Okay. Now, one way of running this loop is I actually count the number of elements in the array and then find that number and then write that number here. Okay. But another simple way is if there are too many elements in the array, you need not even count. You can get the number of elements by using a simple technique. Suppose if there are n elements in the array and we know the array data type. Suppose if it is int. Okay. If integer size is 4 bytes and if there are n elements in the array, what will be the size of the entire array? 4n, n into 4. So size of function can be used not only to calculate the size of a data type, it can also be used to calculate the size of the entire array in terms of bytes. So now can you tell me how to find the number of elements? Huh? Size of a by 4. Yes. In this case, I know that it is integer data type, but suppose in some other compiler size of int is 2 bytes, in some other compiler size of int is 4 bytes. So then rather than using 4 or 2, or suppose I don't even know the data type of the element, then what to do? Exactly. Size of entire array by size of one element, maybe the first element or second element, whatever it is, that will give me the number of elements. Okay. So int number of elements equal to size of a by size of a of 0. That's it. Now a of 0 can be an integer, can be a float, can be a char, it doesn't matter. I will get the number of elements in the array. That's all I want. All right. So now I goes from 0 to number of elements minus 1. Less than means it stops at n minus 1. Okay. That's it. It printed all. You need not worry about counting. This is particularly useful when you're dealing with strings. We will come to strings in a while. Suppose when you have a long sentence or a long paragraph, that entire paragraph is sort of assigned to an array. You don't know the size of the array. Now you want to sort of loop through each character. So rather than counting each character and then telling, okay, for loop goes from 0 to these many characters, you just find the number of characters in that array by doing size of array divided by size of character or size of first element in the array. Okay, as simple as that. All right, now suppose I have, say, only 4 elements and I give a very long array, right? Now suppose if I ask it to print the size of the so let's run this. Let's see what it will do. It's warning saying that you have given more elements than the size of the array. You try to assign more elements than the size of the array. Okay, it stopped there. It took size of the array as 4 only. I mean, size of the array as 4 into 4, 16. 16 by 4, 4. Number of elements are 4. Now suppose if I force it to print beyond 4, say I say go up to print me the first 8 elements. Okay, so what will it do? It's printing some garbage. Okay, it is storing the first 4 elements properly, but the remaining it did not store at all. But it is still printing. What is it printing? It is going beyond the array cells and it is going to the next cells. It is somewhere in the RAM, in the middle of the RAM. So there are cells before the array, cells after the array. There will be some data either being used by this program or being used by some other program. It is trying to read those cells and try to print the data in those cells, which is a security hazard, right? So in that sense, C is not a secure programming language. If you have security sensitive application, you should not use C, because using C, a hacker can access those portions of the memory which should not be accessed. We may not know, but there are some techniques like even if you know what is in the next cell, or even if suppose if you are given complete freedom. So what I will do, I will access the entire remaining RAM. I will download that entire data and I will read it later, right? So that should not be allowed. So for that purpose, you should use some more secure languages like Java, etc. So that is the difference. So C is more useful when you want to do fast processing, like for game development. You need very fast processing. So C is useful there. Even if there are some glitches, it doesn't matter. That's why you will see some glitches in the games. Sometimes, I don't know, there is some term for that. People use that to actually win a level. They go to higher levels using those glitches. Some people actually discovered, you can see on YouTube some videos. They discovered that and they use that glitch to win a level. Okay, so for fast processing things, you need C. But if speed is not a concern, but security is a concern, then use some other language like Java, etc. So each programming language has its own purpose. Okay, now if I run it again, you will get different numbers. Each time I run, you will get different numbers. In this case, you have 0, 0, but even they may change after if you run 10 times or 100 times or whatever. But the point is, it is trying to access cells outside its range, which is not a good thing. All right. Now, suppose I have only 4 numbers, or suppose I have only 3 numbers. Okay, and my array size is say 5. All right. Now, what I want to do, I want to sort of change the values or fill the remaining values. Okay, suppose I say a of 1 equal to 10, a of 3 equal to 7, a of 4 equal to minus 15. All right. So here what is happening? A of 1 means which element? 0, second element. So 0 will be replaced with 10. And then A of 3 and A of 4 means fourth and fifth element. They were by default zeros. So they will be replaced with 7 and minus 15. Okay. So let me print the array before these changes and after these changes. Okay. Okay, so I need to give a new line here also. Okay, so before the changes, it is 3, 0, minus 5. Okay, let's look at the array once. It is 3, 0, minus 5. So it just printed 3, 0, minus 5 and then 2 zeros. And after the changes, 0 became 10. And after minus 5, you will have 7 and minus 15. Okay. You see, 3, 0, minus 5 and 2 zeros. After the changes, 0 became 10. And these 2 zeros became 7 and minus 15. Fine. So this is another way in which you can access individual element and give value to that individual element. All right. Yeah. Okay. So one more thing, you can just now you can use these elements like any variables. So suppose I want to increment each element by 5. All I need to do is increment each element by 5. So what should I write here? Yeah, a of I plus equal to 5. Okay, so let's see. So this is the previous case where 0 is replaced by 10. These two zeros are replaced by 7 and minus 15. Now each of these values are incremented by 5 and printed here. So 3 became 8, 10 became 15, minus 5 became 0, 7 became 12, minus 15 became minus 10. Okay, so you can do any operations like you do on normal variables. You can do all those operations on individual elements. All right. Okay, so let's stop here. We'll continue in the next lecture. This week, lab and tutorials will be only on loops, not on arrays. All right.